Good morning, children.
Good morning, ma'am.
Good morning.
Good morning.
Good morning. So we are continuing with yesterday's topic. This is the next question. Write down the question, children.
Ma'am,
Yes.
I can't see the screen, ma'am.
Children, what about the others? I have shared my screen.
Ma'am, I can see the screen.
Yes, ma'am.
Ananya, maybe leaving and rejoining may help.
Yes, ma'am, will do.
Please try. Yeah. All right. Let's see the first one. In 3 line segments, OA, OB, and OC. All right. In 3 line segments, OA, OB, and OC. So see here. In 3 line segments, OA, I'll explain why it is like this at the end. In 3 line segments, OA, OB, OC, L, M, and N respectively are so chosen. So L is chosen on OA, M on OB, and N on OC. LMN. LMN. This is the line segment OA. L is chosen on OA, M on OB, and N on OC. L, M, and N respectively are so chosen that LM is parallel to AB. LM is parallel to AB. LM, see here? LM is parallel to AB. Sorry, children. One second, I can do it better on the board. You know, this tablet is so slimy, so I'm not getting the grip over the pen. That's the problem. Let me do this also. Sorry. Somebody's mic is enabled. Please disable your mic. Yeah, I think it will be okay now. So see here. Yeah. So we were here. OA, OB, and OC. Okay, L is chosen on OA, M on OB, and N on OC. N on OC. All right. So see here. In 3 line segments, OA, OB, and OC, L, M, and N respectively are so chosen that, so that is, we'll have to choose L on OA, M on OB, and N on OC, such that LM is parallel to AB and MN is parallel to BC. LM parallel to AB. LM, the join of L and M is parallel to AB. Is parallel to AB. So join A, the points A and B. And then MN is parallel to BC. MN is parallel to BC. MN is parallel to BC. So join this. Look at this. But neither of LMN nor ABC are collinear. When 3 points are not collinear, they form a triangle. When 3 points are not collinear, they form a triangle. When you have when you have 3 points in a plane, there are only 2 things possible. When we have 3 points in a plane, only 2 things are possible. Either the 3 points can be connected by the same straight line, which means the 3 points are collinear. If they cannot be connected by the same straight line, that means the points are not collinear, and then they will form a triangle. In that case, they will form a triangle, because when 3 points are not collinear, only a triangle is formed. These are the only 2 things that you see, like when you consider natural numbers, only 2 things are possible. If the number can be odd. If it is not odd, it has to be even. If the number is not odd, it has to be even. Similarly, when we have 3 points in a plane, there are only 2 options. Either the points are collinear or not collinear. If they are collinear, no triangle is formed. If they are not collinear, a triangle is formed. Okay, so that's what is meant by neither of L, M, and N. nor ABC. So neither these 3 points nor these 3 points are collinear. That means these 3 points form a triangle and these 3 points also form a triangle. Because L, M, and N, they are not collinear. ABC are not collinear. If they are not collinear, the only other thing possible is they form a triangle. So LMN is a triangle, ABC is also a triangle. And with this, we need to prove that LN is parallel to AC. LN is parallel to AC. We need to prove that LN is parallel to AC. So this one is in your NCRT, the second exercise. I don't have the textbook with me. I'm not in town, so I don't have any material with me now. This is in your NCRT. But there the figure is given. The description is not given, meaning the figure is given directly and the information is LM is parallel to AB, MN is parallel to BC. Prove that LN is parallel to AC is the question in NCRT. So sometimes this can be given in words like this. Is this understood, children? You know the proof. Is this understood, children?
Yes, ma'am.
Yeah. So since the points L, M, and N are not collinear, they form a triangle. Again, the points A, B, C are not collinear, so they form a triangle. L is a point on OA. M is a point on OB. N is a point on OC. LM is parallel to AB given. MN is parallel to BC given. We need to prove that LN is parallel to AC. Kanishka, quickly tell us this proof.
Ma'am, in triangle OAB, LM is parallel to AB, ma'am. So OL by LA will be equal to OM by MB, ma'am.
By BM or MB, correct? Okay.
Yes.
1 minute, 1 minute, 1 minute. By reason? Reason?
One minute, ma'am.
Yeah.
Basic proportionality theorem, ma'am.
Yeah, BPT. Basic proportionality theorem.
I didn't get the word.
Correct.
All of a sudden, I didn't get the word.
Right. Yeah.
And then in triangle OBC, ma'am. OM by MB will be
parallel lines.
Parallel lines or MN parallel to BC, ma'am.
Okay.
And OM by MB will be equal to ON by NC, ma'am.
Okay. Reason?
Same BPT, ma'am.
Okay.
Since OM by MB is common in both, and they are equal to OL, LA, and ON and NC, OL by LA will be equal to ON by NC, ma'am.
This is in which triangle? These line segments are in which triangle?
OAC, ma'am.
In triangle OAC. Yeah. So therefore,
LN will be parallel to AC, ma'am.
By?
Ma'am, converse of BPT.
Very good. By converse of BPT. Yeah, those who want to practice working this, please take a screenshot. Or maybe I can wait for 3 minutes. Yeah, please write down. If you want to work it in your book, please take it down now. Okay, next one. Any point X inside you have you all written the question? All of you have the question? Okay. So look into your book for the question. I'm using the second one, this one. Both the questions represent the same situation. Just that the points are named using different letters. Here it is D, E, F and P, Q, R. In the first one, it is ABC and LMN. ABC, LMN. In the second one, it is D, E, F and P, Q, R. The situation is the same. So the question can also be given like this. For the same situation, the description can also be like this. Any point X inside triangle DEF. Triangle DEF. Triangle DEF. Any point X. So some point X. Any point X inside triangle DEF is joined to its vertices. Is joined to its vertices. Okay, is joined to its vertices. It's a straight line, children. Please excuse me. Go on. Okay, it's joined to its vertices. So take any point X inside the triangle and join the point X to the vertices D, E, and F. From a point P in DX, from any point P in DX, PQ is drawn parallel to DE. So PQ is drawn parallel to DE. So like this, no, see here, PQ is drawn parallel to DE. Meeting XC, yeah, it does meet XC at Q, this is Q. And QR is drawn parallel to EF. QR is drawn parallel to EF, Meeting XF in R, meeting XF in R, this is X. Meeting XF in R, Prove that PR is parallel to DF. So you should join. Prove that PR is parallel to, you should prove this, it's not given. Prove that PR is parallel to DF. Let's see it again. Triangle DEF. Triangle DEF. Any point X inside the triangle is joined to its vertices. So join X to D, X to E, and X to F. From a point D, from a point P in DX, from a point P in DX, PQ is drawn parallel to PQ is drawn parallel to DE. So this is DE. So PQ is drawn parallel to DE. PQ, this is Q, parallel to DE. Meeting XC in Q. It meets XC in Q. And then QR is drawn parallel to EF. So it has to go like this. QR is drawn parallel to EF, meeting XF in R. So these are parallel. Prove that PR is parallel to DF. PR. Prove that this one is parallel to DF. All right, children. So
Yes,
both so both represent the same situation. So the question can also be like this. The situation can be given and you have to make the diagram and then prove. Yeah, I'll just wait for a minute just in case you want to draw the diagram in your book. The second figure, you may draw it in your notebook. All right. Yes, you can try this one. Please try. Okay, those of you who have started, like working, tell me, are you using Thales theorem, that is BPT, or what are you using?
BPT.
Yeah, one by one, tell me. You have started working.
BPT.
One by one. Sneha and Harini.
Ma'am, by BPT, ma'am.
Okay, you started by using BPT. Ananya.
I'm not sure either BPT or similar triangles.
Okay, BPT or similar triangles. Deepika. Okay, Kanishka.
Ma'am, BPT.
Okay, Nandini.
Same, ma'am, BPT.
Same. Pranav, Rajeshwari, Pranav.
BPT, ma'am. BPT.
Rajeshwari.
Ma'am, I too have doubt with the similarity at BPT. ma'am.
So you'll try probably Ananya and Rajeshwari, you'll try BPT. If it's not working, you will like proceed with similar triangles because we have no other choice, right?
Yes, ma'am. Yes, ma'am.
Yes,
Very
ma'am.
nice. Okay, fine. Ram,
BPT, ma'am.
Kashmir, Shreya Shri,
Ma'am, BPT.
Lakshmi,
Ma'am, similar triangles.
similar triangles. Okay, Tarun,
Ma'am, BPT, ma'am.
BPT. All right, fine. So what I would like to tell here is BPT will connect only these two sides of the triangle. If it is about these two, meaning if now in this case, this is parallel to this. If you want to get some relation between these two sides of the triangle, then you can use BPT. But you have to prove that AD bisects PQ. This is PQ. This is PQ. You need to prove that PQ is bisected. That is, you'll have to prove that PE is equal to EQ. When it is about these sides, then you have to go with similar triangles. Similar triangles, using similar triangles, you can write a ratio on all the three sides of the triangle. But BPT, you have the ratio based on any two sides of the triangle. When you write the proportion using BPT, you will be using the line segments on some two sides of the triangle. When you use BPT to write the proportion, you will be using the line segments of any two sides of the triangle. The third one will not at all be there. But when you prove that two triangles are similar, that will connect all the three sides of the triangle. Of course, BPT is using one triangle, but similar triangles is using two triangles. But I'm trying to say that BPT connects only two sides of a triangle. While in similar triangles, when you write the proportion, that is in similar triangles, corresponding sides are proportional, you get a ratio on every side of the two triangles. So since here it is, here we have PQ parallel to BC, we have PQ parallel to BC, and we know that, BPT will connect only this. BPT will connect only this. And this one. So I think you have to use similar triangles. You can try, those who said BPT can try it. But BPT will not connect the third side, PQ and BC. Okay, so Lakshmi confidently said similar triangles, but Rajeshwari and Ananya were also right. You said you will try some BPT, but both of you sounded like as if BPT will not work, and that's why you had the next choice, similar triangles. Good, three of you. Okay, so I think I'm not explaining, you can just do it by yourself.
12,000 rupees on Google Pay for Business.
Just coming back, children, please write on this.
Ma'am? Ma'am?
Children, I had excused myself. I'm sorry, but somebody was calling out to me.
Yes, ma'am. Ananya.
I'm sorry. Yes, Ananya.
Ma'am, I have a small doubt. How is PE by BD equal to EQ by DC?
Oh, have I gone wrong? Where, dear? Where?
No,
Yeah.
ma'am, I have a doubt.
Where?
How is PE by BD equal to EQ by DC?
Okay, fine. All right. I thought in both the proportions, what I've crossed is common, right? In proportion 1 and 2, I've crossed two things, no? AE by AD,
Yes,
AE by AD.
Yes, ma'am.
They are common, right? So AE by AD is in 1 and 2.
Oh, so the rest of the proportion, since it is equal to A by AD, will also be equal to each other.
Yeah, correct. Now we'll just take an example. Supposing AE by AD is 7 by 8. So here also it's 7 by 8, right? And
Yes,
7 by 8 is equal to 7 by 8 is equal to 7 by 8. So this is all are 7 by 8. All are equal to 7 by 8 then.
Yes.
So they're equal to one another. All the 6, there are 5 only actually, because 1 is common. All the 5 ratios are equal to one another.
Okay, ma'am. Thank you.
Yeah. So in 1 we have the ratio, class in 1 we have the ratio AE by AD. In 2, see I've marked this 1. I've marked this 1, and this one as 2. In both 1 and 2, we have a common ratio AE by AD. You can see here I've crossed it. AE by AD is common in 1 and 2. So that means all the ratios are equal to one another. So that means PE by BD is equal to EQ by DC. And why have we chosen that? Because these two ratios have, what we need to show. We need to show that PE is equal to EQ. So see here, we need to show that PE is equal to EQ. PE is equal to EQ. So I have PE here and I have EQ here. So I take these two ratios. This one is not needed. This one is not needed. These two. You can finish, you can prove with these two ratios itself. So PE by BD is equal to EQ by DC. But we know that BD is equal to DC. It's given here. AD is the median on BC. AD is the median on BC. So that means D is the midpoint of BC. So BD is equal to DC. But BD is equal to DC because AD is the median. AD median on BC. AD is the median on BC. So BD is equal to DC. So that means BD is equal to DC, meaning this is BD and DC, they're equal. So therefore, P is equal to EQ. Understand, class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Very good. Okay, next one. Yes, Chinna. We'll give you some time for you to think. Yeah, children, have we all started? DPT, similar triangles. BPT or similar triangles?
Similar triangles.
Shreyashri, is it?
Yes, ma'am.
Yes, Shreyashri, tell me.
Ma'am,
In triangle. Yeah, just read out what you have written. In
ma'am,
triangle.
DFG
Yeah.
and triangle ABD.
Yeah, or DAB. Very good.
Angle DGF.
DGF. Let me number it. Let me number it.
Yes, ma'am.
Yeah, tell me. Angle.
DGF.
No, I've numbered it. No, please use the numbers.
And angle 2 is equal to angle 3.
Reason?
Corresponding angles.
Corresponding angles. Okay, then angle. Then the second one.
Angle 1 is equal to angle 1 common.
Very good. Very good. Angle 1 is equal to angle 1. Angle 2 is equal to angle 3. Corresponding angles, because it's given that EF is parallel to AB. It's given EF is parallel to AB. Very good. So therefore,
by AA criteria, triangle DFG is similar to triangle ABD.
So tell me the order. DFG is similar to
DBA.
If you say DFG, then you must say
DAB.
DAB, DAB, DFG, DAB by AA similarity criteria. Yeah, now the proportion.
Ma'am, DF by DA is equal to.
Yeah, you're right.
FG by AB.
Yeah.
Which is equal to DG by GB.
Very good. What is the reason, Shreya? What is the reason for this?
Ma'am, BPT.
No, not BPT. Because in similar triangles, corresponding sides are proportional. All right. Corresponding sides are, proportional. Because in two similar triangles, corresponding sides are proportional. Very good. This is the first one. Next, in triangle.
In triangle BGE.
Yeah, BGE.
And BDC.
Very good. BDC. Yeah.
Angle 4 is equal to angle 4.
Okay. Then?
Angle 5 is equal to angle 6.
Okay. Reason why 5 is equal to 6?
Corresponding angles.
No, but FE is not parallel to DC, no? FE is not parallel to DC. It's not given that FE is parallel to DC. Corresponding angles are formed only when you have parallel lines intersected by a transversal. Yeah, class. FE is not parallel to FE is not given to be parallel to DC. Who can answer that? Correct, Rajeshwari. Correct, Rajeshwari. Yes, I heard it from you first.
Ma'am, AB is parallel to DC, ma'am, and AB is also parallel to FE, ma'am. So FE is also parallel to DC, ma'am.
Correct, very good. Since AB is parallel to DC and AB is also parallel to FE, two lines parallel to the same line are parallel to one another. So here the two lines are DC and FE. They are parallel to the same line AB. So they are parallel to one another. That means DC is parallel to FE. FE. Two lines, DC and FE, are parallel to the same line AB. Is given to us. Is given to us. So they are parallel to one another. So DC is parallel to FE. Yes, continue, Shreya.
Yes, ma'am.
Triangle?
Triangle BGE
Correct.
is similar to BDC.
Very good. BDC. Correct. Double A. Now?
BG by DG.
BG by?
DG.
No, you're saying using that is BPT. BG by what?
BG by BD
BD is equal to?
is equal to G by DC.
Is equal to?
B by BC.
Yeah. What's the reason?
In similar triangles, corresponding sides are proportional.
Very good. In similar triangles, corresponding sides are proportional. Yeah. Now, is it possible to compare 1 and 2?
Yes, ma'am.
How? What is common? Okay, you unmute your mic. Once you get the answer, you can, sorry, you put your mic on mute. Let me know if you get the answer for that.
Yes.
Yeah. Yes, class, tell me how to proceed. Very simple. Think. I'll also just come back, children. I'll just get back in 2-3 minutes. See, children, use the ratio. It's given, no, BE by EC is equal to 3 by 4. BE by EC is 3 by 4. That means BG by GD. BE by EC is 3 by 4. So what is BE by BC?
3 by 7.
3 by 7. Please, yeah, that's all. It's very numerical. BG by, so BG by BD also will be 3 by 7. GE by DC also will be 3 by 7. Okay, you think about this and tell me. I'm writing the next question. You can do this because it's given. It's very straightforward. BE by EC is given 3 by 7. So BG by BD. You can find most of the others using this. Yeah, I hope you've all written till here. So I'm just writing the next question. You think? Anybody can answer this? No? Okay, we'll do it together then. So now you cannot compare these two proportions because there's nothing in common. There is no ratio common to both, so you cannot compare. So what we have to do is, now what is FE? See, you need to get FE and AB in the result. In the result, you need to get FE and AB. Let's try to write this in the form of a ratio. Just a second. Vare. So we'll just write this in the form of a ratio. What will we get for FE by AB? FE by AB. What is FE by AB, children, from this one? 10 by 7 or 7 by 10?
10 by 7.
Correct. This is what we should get. So FE by AB, you must get FE by AB. You must get FE by AB is equal to 10 by 7. Only then when you cross multiply, you'll get 7 times FE is equal to 10 times AB. So now we'll choose the relevant proportions from here. So see here, we have FE and AB. Look at this one, FG and AB, FG and AB, and then what is this? DF by DA. You can take anything actually, DG, because you know the ratio for everything. You take any two ratios from there, but from here you take any two ratios, but you should take FG by AB. Now from one, supposing you take DF by DA, DF by DA is equal to FG by AB. Okay, FG by AB. Take any two, children, but it should have FG by AB, because in the final result we have FE. FE is nothing but FG plus GE. FE is nothing but FG plus GE. FE is FG plus GE. So we want the ratio which has FG. And here we will take this one, GE. We will take this one. From the first proportion, we will take this ratio. Because we have FE and AB in the final result, FE is made up of FG and GE. FG is here and GE is here. So we will take these two ratios from the first and second one. So FG by AB is equal to DF by DA. Now, because B by EC is equal to 3 by 4, you know by BPT, see, this is 3 parts. So this is 3x and this is 4x. So by BPT, BG is also 3x, right? By BPT, this is 3x. This is 4x. And this one is 3x, 4x. You can use this intercept theorem also here. Instead of working BPT, you can use the intercept theorem. If 9th standard, you can use the intercept theorem. If three parallel lines are intersected by two or more transversals, the ratio of the intercepts on one transversal is the same as the ratio of the intercepts on any other transversal. See, so you can use that. See, when three parallel lines are intersected by two or more transversals, see, you can have three or more parallel lines also. I'm talking with respect to the situation. When three or more parallel lines, so here 3 parallel lines are intersected by 2, 3 or more transversals. The ratio of the intercepts, this is an intercept. This is an intercept. The ratio of the intercepts on any one transversal. So supposing here the ratio is 3 by 4. It will be the same on any other transversal as well. If 3 or more parallel lines are intersected by two or more transversals, then the ratio of the intercepts, on one transversal is the same as the ratio of the intercepts on any other transversal, So when you have three or more parallel lines intersected by transversals, you can have any number of transversals. Now this is an intercept. Intercept is a portion of the transversal between two parallel lines. Intercept is the portion of the transversal between two parallel lines. So if the ratio of this intercept is say like 7:8. So this also will be 7:8. This will be 7:8. This also will be 7:8. This also will be 7:8. That means you don't even have to use BPT. So you can just mention this theorem. So if this is, so see if AB, FE and DC are the three parallel lines. And see the transversals, AD is a transversal, BD is a transversal, BC is a transversal. So we have three parallel lines, AB, FE and DC, intersected by three transversals, AD, BD and BC. And the ratio of the intercepts on the transversal BC, the ratio of the intercepts on the transversal BC is 3:4. BE, intercept BE is 3 parts, intercept EC is 4 parts. Then BG is 3 parts, GD is 4 parts, AF is 3 parts, FD is 4 parts. Am I clear, children? Not clear? Shall I repeat?
Yes, ma'am.
Yes, ma'am.
Shall I repeat, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, sure. Let me write this again. We have three parallel lines, children. Now these are three parallel lines. Okay. Next, you can take any number of transversals. I'm taking according to this situation. There are three transversals. Okay. 1, 2, 3. 3 transversals. Okay. Now what is an intercept? An intercept is a region of the transversal between two parallel lines. So see, this is an intercept because it's a portion of the transversal between the two parallel lines. This is an intercept. This is an intercept. 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 Is it understood so far?
Yes, ma'am.
Okay.
Yes, ma'am.
Now let me call this A, B, C, D, E, F, G, H, I. Now it is the ratio of the intercepts AB and BC is given. The ratio of the intercepts AB and BC is given. Supposing it's given to be 3/8. 3/8. Then what are the other ratios of the intercepts we have here? We have DE by EF. DE is an intercept. EF is another intercept on the same transversal. There are three different transversals. The ratios of the intercepts on the transversals are AB by BC, DE by EF, and what is the last one? And what's the last ratio?
GH by HI, ma'am.
GH by HI. Now, if the ratio AB by BC is 3 by 8, then all this will be 3 by 8. The ratio will be 3 by 8. Their lengths may be, see now, maybe this is like, say 4 3s are 12, 4 8s are 32. This is 5 3s are 15, 5 8s are 40. So DE may be 15 centimeters and EF 40 centimeters. This is 12 centimeters. This is 32 centimeters. The ratio will be the same. What is 12 by 32? 3 by 8. What is 15 by 40? 3 by 8. The ratio is the same. I can do it again, children. If you don't understand, please tell me now.
Understood, ma'am.
Yeah, others? Please respond.
Yes, ma'am.
Understood.
Understood.
All right. So, okay, good. So if 3 or more parallel lines are intersected by 2 or more transversals, the ratio of the intercepts on any one transversal will be the same as the ratio of the intercepts on any other transversal. Or the ratio of the intercepts of the transversals will be the same. So using that, oh, this I shouldn't have done. Sorry. This was different because AB is parallel to AF and what else is given? AB is parallel to DC. Okay, this is different. Okay, fine. So till here you all understood. Now you will have to mention the theorem. You'll have to mention the theorem. Okay, the theorem behind. So by the theorem, BE by EC will be equal to BG by GD will be equal to by FD. All will be equal to because BE by EC is 3 by 4. All this will be equal to 3 by 4. Is this understood, children, by the theorem?
Yes, ma'am.
This is called the intercept theorem. Intercept theorem. Intercept. You have learned it last year. You have not learned the intercept theorem, but then midpoint theorem. What is the chapter? Quadrilaterals. Midpoint theorem, converse of midpoint theorem. There you've learned this ratio. This is the intercept theorem. Intercept. Okay, let's continue. Now, from 1, we are picking a ratio. A proportion. From 1, we are picking a proportion. From 1, we are going to pick a proportion. Which one are we going to take? Which 2 ratios are we going to take? We're going to take this one because it has FG. This one because it has FG. Read this one. DF by DA. You can take this also. You know the answers on this. This is DG by this is DG by DB. You can take any one. You have to take FG by AB. You have to take FG by AB because it has FG. Why you need FG? Because FE is made up of FG plus GE. So you have to take this one. This along with anything else, children. Let me put it like that. This along with anything else. So supposing you take DF by DA. DF by DA is equal to FG by AB. FG by AB. All right. So what is DF by DA? What is DF by DA, children? Tell me. How much is DF? All 3/4 children. 3/4. This is 3 parts. This is 4 parts. This is 3 parts. This is 4 parts. Please tell me how much is DF, children? DF.
4, ma'am.
4 parts. 4x. And how much is DA?
7.
7x. So 7x. Yeah. So 4x by 7x is equal to FG by AB. Then from 2, pick the one which has GE. Pick the one which has GE. This one you should take. Then take any one ratio. Maybe we'll take this one, B by EC. B by EC. So GE by DC is equal to BE by BC. BE by BC. So now GE by DC, but you know something, DC is also given as twice AB. DC is twice AB, so you can, that will be useful. Replace that. Twice AB is equal to BE by BC. BE by BC is, you can see that, 3x by 4x. Yes or no? Sorry, 3x by 7x. BE by BC, 3x by 7x. 3x by 7x. Now take this 2 here. So it will become G by AB is equal to 6x by 7x. Yes or no, children?
Yes, ma'am.
Okay, so this will get cancelled. This will get cancelled. So you have FG by AB is 4 by 7 and G by AB is equal to 6 by 7. Now add these two. FG by AB plus G by AB is equal to 4 by 7 plus 6 by 7. So FG plus GE by AB is equal to 6. Okay, 4 plus 6 by 7. So FG plus GE is FE. So FE by AB is equal to 10 by 7. On cross multiplying, 7 times FG is equal to 10 times AB. 7 times FG is equal to, oh, we need to get, oh, I have not, sorry, I have not added correctly. FG plus GE is FE. FG plus G is FE. I've gone wrong in writing. FE. Not FG. FE. All right, children?
Yes, ma'am.
Yeah. So use similar triangles. Use the concept of similar triangles. Write the proportions. So there's a different idea. You need to remember this idea. You need to memorize this idea. Remember this idea. That's why they have given you a relationship between DC and AB. So wherever you have DC, you can use twice AB. And you need to get AB in the result. So DC can be replaced with AB. And FE is what? FG plus GE. So we find FG. We find FG by AB from one, GE by AB from the other, FG by AB, GE by AB. And we add both to get FE by AB. See here, I can tell you from here also. See here. Now this FE is what, children? Listen to me now, please. So see here, you should get FE by AB is equal to 10 by 7. What is FE, children? FG plus GE, right? By
Yes.
AB. Yeah, is equal to 10 by 7. So there's nothing but FG by AB. FG by AB plus GE by AB, correct? This you must get as 10 by 7, correct? Just interpreting the final result. So we found FG by AB from 1, FG by AB from 1, and then GE by AB from the other. We add both to get FE by AB. Yeah, I'll show you the slide. Write down. Done, children? Finished writing? Anyone wants me to show the earlier slide? Okay. Yeah, take down this one. Try this, children. Yeah, try these two, children. I'll just get back. Yeah, I want the answer for the fourth one from somebody. Please volunteer to answer the fourth one. How many of you have completed the fourth one? Raise your hand. Use the emoji, raise your hand. How many of you finished working the fourth one? Okay, how many of you think you do not know how to answer the fourth one? Am I audible? Raise your hand. Then please tell me, children, what is the problem? Okay, you answered 1 and 2, but not able to answer 3 and 4, is it?
Yes, ma'am.
Oh, finally. Okay, Kanishka. Okay, 1 and 2 you were able to do, Kanishka, but 3 and 4 not able to do. Okay.
Yes, ma'am. I'm still working on the 3, ma'am.
You are still working on 3. Yes. Yeah. Now
Yes, ma'am.
Kanishka.
I'm trying.
Yeah. What about the others? Ananya.
Third subdivision.
Shreyashri.
Ma'am, third one.
Ram.
First two completed, ma'am. Third one.
Okay. Tarun.
Ma'am, third one, ma'am.
Okay. Rajeshwari.
Third one, ma'am.
Sneha Harini. Lakshmi.
Third one, ma'am.
Okay. Kanishka also said the same thing. Sashmin and Deepika. Normally you're not able to answer, so I'm not asking you. Okay, fine. I'll give you some more time. All right.
Ma'am, aren't 1 and 2 90 degree?
Oh, yeah. 1 and 2. Thank you. So 1 and 2, similarity. I'm sure all of you must have done it. Then proportion. Vare. Then proportion. You'll have to select the two ratios which can be cross multiplied to get the result in 2. You'll have to select the two ratios. So these two ratios, when cross multiplied, will give you the second result, this result. So we got it, but then they look different here. So write AC as CA, then this EC as CE, BC as CB, DC as CD. So both are the same. This one and this one, they're the same, but just present it the way it is given in the question. Okay, now you have to prove that. Is this any questions still here, children? Most of you said you have completed 1 and 2. Okay, now the third one. You'll have to prove that triangle ABC is similar to DEC. So we need to join. DEC is this triangle. DEC is this triangle. So you'll have to connect D and E. Because you don't see the triangle DEC, right? You can only see the points D, E, and C, but you don't see the triangle formed by these 3 points. And now you can see it. After connecting the points D and E, you can now see the triangle DEC. So connect the points E and D or D and E. Now see, it's not given that D is parallel to AB. It's not given that D is parallel to AB. So you cannot say corresponding angles are equal. So as of now, between the two triangles, there is only one angle common. That is angle 3. There's only one common angle, which is 3. Now the other comes from this proportion. So we're going to prove that these two triangles are similar by SAS similarity criterion. So we're going to pick a suitable proportion from this one. That is, pick those two ratios from this result which form the sides of the two triangles DEC and ABC. So now let's select. So this is the third subdivision. Let us select now AD. AD no. BE no. DC yes. DC yes. And EC yes. AC yes and BC yes. Yeah. So we can go ahead with these two ratios. We can go ahead with these two ratios. Why? Because these two ratios, that is, these two ratios which have 4 line segments, those 4 line segments are the sides of the triangles DEC and ABC. So we go ahead with those two ratios. Let me call this 1. Let me call this one 1. So using 1 or from 1, using 1, DC by EC is equal to AC by BC. But you know that the proportion to use essays, it should be like side of one triangle. Let me say small and big triangle here. There's one is small, the other is big. So you must have the proportion like this, which reads like this. Side of the small triangle by side of the big triangle is equal to side of the small triangle by side of the big triangle. Your proportion should read like that. So now just select from here. What is DC? So use that alternando. Use alternando, children. We saw in one of the earlier classes, some classes, Rajeshwari had texted me that she had exams at school. So Rajeshwari, you did not attend the last 2 classes, not Saturdays. Oh yeah, 3 classes you missed, right, Rajeshwari?
Yes, ma'am.
Yeah, so I request you to watch the recordings because yesterday and even the last 2 classes we did some important questions from, I'm not able to recall, but all the video, all the meeting recordings are promptly uploaded in the playlist. I make sure I do it that day itself so that children who miss the class can use the recording and come prepared for the next class. And since this is a revision program, every class, whatever the contents of every class will be important, is important from the examination point of view. These and now yesterday and today we are seeing the different questions which can be expected in the board exam from similar triangles. So do not forget to watch the recordings, children. Ananya also a few classes you have missed. Then Sashmin is not here for a long time. Maybe you had exams at school. Shreyashri also missed a few classes. Kanishka missed. Sneha and Harini also were not there, I think, last week. I think as far as I can remember, I think I did real numbers. Last Saturday and Sunday, I think we did real numbers. So students who have missed classes, please watch the recordings. Yeah, now use alternando. So these terms I've used in the classes earlier. Alternando, invertendo. Now use alternando. So exchange these two. Exchange these two. Okay, so you can write this as DC by AC is equal to EC by BC. DC by AC is equal to EC by BC. DC of the small triangle by AC of the big triangle is equal to EC of the small triangle by BC of the big triangle. See, how should the proportion look like to use it for similarity of 2 triangles? Any side of the small triangle by any side of the big triangle is equal to any other side of the small triangle by any other side of the big triangle. Now you might, I'm sure you have this question in your mind that DC is here, well AC is here, how can you use a proportion? It's fine. See, DC is a side of the small triangle. AC is a side of the big triangle. That's all. Their ratios are the same. The ratio of this ratio DC by AC is the same as AC of the small triangle by BC of the big triangle. It's fine. It can be like that. All right. So if it is a learning, remember this. Remember this. So we use alternando. We use alternando I can write it like this for you. DC of triangle DEC by AC of triangle DEC by AC of triangle ABC is equal to ECBC, ECBC, ECBC. And I think I named the vertical angle 3. So angle 3 is equal to angle 3 common angle. Common angle. So now again, how to write the proportion? I've told you this. DC by AC is equal to, C is the letter common. So write it like CE by CB. I've told you that. DC, CE. The common letter is C. So DC, CE, AC. See, this is about these are the sides of the small triangle. These are the sides of the big triangle. So DC, CE, AC, CB, DCE, DCE is similar to ACB. Is similar to ACB. So triangle DCE is similar to triangle ACB by SAS similarity criterion. But how is it given here? ABC, DEC, ABC, DEC. Okay, see here. ABC. So they've exchanged this. ABC. So then it should be here. C and B are exchanged. So here E and C. DEC. DEC, ABC. Here DEC, ABC. We got the same thing. Is similar by same thing. SA similarity criterion. SA similarity criterion. So now the proportion. You need to show that CD by AB. CD by AB. So write all the 6. D by AB is equal to EC by BC is equal to DC by AC, because in similar triangles corresponding sides are proportional. Now cross multiply. We need to get CD and CA. CD, CA. Yeah, here it is. And then ABD here, this one. So take these two ratios. So D by AB is equal to DC by AC. On cross multiplying, you get DE into AC. Yes, children. Please write down. By alternate. Done writing, children?
Yes, ma'am.
All right. So this is how we use SAS. SAS is, we need to, of course, take up the sides of the triangles which we need to prove are similar. So two triangles, if you call them small and big, so it should be like the proportion should be like this. Any side of the small triangle or big triangle first. You can write big by small or small by big again. So any one side of the small triangle by any side of the big triangle is equal to some other side of the small triangle by some other side of the big triangle. That is the proportion. It need not be, it need not be CE by CA. As in our case now, it's CE by BC. CE is on this side, BC is on the other side. That's fine. And why did we use alternando here? Because both were the sides of the same triangle. That's why. See, when you read this proportion, DC by EC. DC is of the small triangle. EC is also of the small triangle. AC, BC. AC is the big triangle. BC also big triangle. So we wanted to write it like small, big, small by big, small by big. So we use alternando. We exchange this. Then when we read it, it sounds just fine. 3 is the common angle. Now, how do you identify which angle to take? DC and EC should include that angle. The sides, the DC and EC must contain the angle contained by DC and EC. Only that you should take, not any angle. Which is the angle contained by DC and EC? DC and EC. DC and EC contains angle 3. So you should take 3 only. You must take 3. Then which is the angle contained by AC and BC? AC, BC, BC, angle 3. That is important, not any angle, any two angles equal. When you're using SAS, the sides which you have taken the proportion, they contain an angle. That angle you will have to say, not any angle. So here 3 is the angle contained by both the sides, both the pairs of sides in the two triangles. DC, EC contain angle 3. AC, BC also contain angle 3. If they're two different triangles, like two different triangles, they're not connected, one triangle and then another triangle. You will not get 3 is equal to 3 common angle. You will get some angle of one triangle is equal to some other angle of second triangle. That's also correct. Those two sides must contain that angle. That is like the included angle in congruent triangles. It's the included angle. DC and EC should include that angle. AC and BC should include that angle. Those two angles must be equal. Here it happens to be the common angle. Not always it has to be the common angle. When there are two different triangles altogether, then how will you have a common angle? Then the two sides which we have mentioned, the angle included by the two sides of one triangle should be equal to the angle included by the two sides of the other triangle. That's how SAS is used. Is it fine, children?
Yes, ma'am.
Yes.
All right. Nice. We'll just do this one and wind up the session for today. Prove that CD square is equal to BD into AD. So whenever you have to get results like this, it is just a proportion cross multiplied. Whenever you have some product is equal to some other product. Some product is equal to, see here, CA into CE is equal to CB into CD. So some product, a product CA into CE is equal to another product CB into CD. So whenever you have to prove the two products are equal, it's just cross multiplying a proportion. You just have to cross multiply a proportion. And from where will you get a proportion? Either by using BPT or similar triangles. It can be BPT also. to get a proportion, you will have to use BPT or similar triangles. And when you cross multiply two ratios, you can get a product equal to a product. Now here you see that CD squared, that is, you will have to prove that CD into CD is equal to BD into AD. You'll have to prove that CD into CD is equal to BD into AD. Now what is important is, since you have CD square, you must take two triangles that have CD as a common side. Only then you will get this result. Whenever you have CD square, AB square, AC square, when you have to get such results, you have to take two triangles that have CD as a common side. Only then you will get CD square is equal to. If it is AB square, you should take up two triangles that have AB as a common side. If it is BC square, you must take up two triangles that have BC as a common side. Those two triangles you'll have to prove are similar, proportion, cross multiply, you will get the result. Yeah, children, tell me two triangles that have CD as a common side. In triangle?
ACD and BCD.
A
DC.
ADC and
Triangle BDC.
BDC, yeah. So these two triangles have DC as a common side. You have to show that these two triangles are similar. Only then you will get the result CD square is equal to. Remember that. CD square. So the choice of the triangles. Take two triangles that have CD as a common side. Two triangles must be proved are similar. Proportion, cross multiply. Yeah. Yes, children, first one. Let me number this. Okay, this is angle 1. This full thing is angle 1. This full thing is angle 2. So angle 1 of ADC. Oh, no, 1 minute. 1 second. Sorry. Let me draw the diagram again, children. All if you draw the diagram again. It's for the proof. Don't make any changes in the question figure. Question figure is correct. Question figure is correct. Don't change that. Now you mark this extra 90 degrees here also. So ADC angle 1, ADC angle 2. Yeah, then what's the next one?
Angle C is what angle C common.
C is not an angle of any of the two triangles. You know what part of C is in ADC? In ADC, we have only this one. And in BDC, you have this much. But these two put together only is C. C is these two put together. C is not the common angle.
Oh, okay, ma'am.
Yeah, C is not common, meaning the whole thing, the full angle should be present in both the triangles. Here, one part of C is in one triangle, the remaining part of C is in the other triangle. That is not how you should consider common angle. Yes, past class. Okay, so again, this is very, very important. We have seen this. So these ideas are what you'll have to remember. Okay, mark all the angles. Mark all the angles in this triangle. So mark this 3, 4, 5, 6. Mark off all the angles, children. Okay, now let's write all the results we can get from these two triangles. Just continue here. I'm continuing here, children. Now, is this correct, children? Angle 5 plus 6 is 90. Am I right? Say yes or no.
Yes, ma'am.
Yes, ma'am.
Like this, give me other results like this. We can write 2 more. Please give me other results like this.
Angle 3 plus angle 5.
Angle 3 plus 5 is 90. Very good. Another one?
Angle 6 plus angle 4. Angle 3 plus
Very
angle
good.
4.
4 plus 6 is 90. Very good. Now compare these two. Compare. From what and what you will get what, and from what and what you will get what.
From 1 and 2, we will get angle 6 is equal to angle 3, ma'am.
Very good. So from 1 and 2, from 1 and 2, angle 5 plus angle 6 is equal to angle 3 plus angle 5. So 5 gets cancelled on both the sides. So angle 6 is equal to angle 3. This itself is enough. Angle 6 of one triangle is equal to 3 of the other triangle. This is enough. But let's just do the other one also. From angle, from, tell me the other
From
one.
1 and 3, ma'am.
1 and 3. From 1 and 3, angle 5
Angle
plus
5
angle
is equal
6
to
is equal. Very good. 4 plus 6. So 6 gets cancelled. So angle 5 is equal to angle 4. So this is one information. 6 is equal to 3. Angle 6 is equal to angle 3. 6 of one triangle is equal to 3 of other triangle. 5 of one triangle is equal to 4 of the other triangle. So what you can do is you can just prepare this one first. You prepare this first. Then you take up the two triangles. You present it in the exam. You first prepare this. Now you say in triangle. You can call this A, this one as B. And then you can just write triangle 1 is equal to angle 2. And you can call this C. From A, B, and C. From A, B, and C. Triangle ADC. Triangle ADC is similar to triangle. If you say ADC, you must say C, because which are the angles equal? One minute, children, listen to this carefully. ADC, just number it. All of you, please listen to me. Please listen to me. ADC, I'll number it. A is 3, D is 1, C is 5. Now, what is 3 in the other triangle? 6, no? 3 is 6 in the other triangle. So I should write which letter first? Okay, 3, 1, 5. 3, 1. 3 means 6 in the other triangle. Then 1 means 2 in the other triangle. And 5 means 4 in the other triangle. So where is 6 marked? At C. Where is 2 marked? At D. And where is 4 marked? At B. This is the order, children. Because angle 3 is equal to angle 6. Angle 1 is equal to angle 2. Angle 5 is equal to angle 4. This is the order. I'm continuing here. So the proportion is AD by DC. Oh, sorry, AD by CD is equal to AD by CD is equal to DC by BD. This is enough. Cross multiply this, you'll get CD square is equal to BD into. I've not written this correctly, I think. AD it is, sorry. So CD square is equal to BD into AD. Isn't it easy, children?
Yes, ma'am.
Very good. So children, first see, as soon as you see the figure, you realize that you cannot, okay, let me not talk like that. So CD square means two triangles which have CD as a common side. So we selected the two triangles. Now we don't have sufficient information. We only have 90 degrees. So you do this preparation first, mark all the angles. Then write the sum. Wherever the sum is 90, write all that. Wherever the sum is 90, write those results. Then compare those results. You will get some new results. And you already have 1 is equal to 90 degrees. So now you have 3 pairs of equal angles. So from A, B, and C, the two triangles are similar by the AAA, by the AAA similarity criterion. Now when triangles are similar, corresponding sides are proportional. Cross multiply, you will get the result. Easy, not easy? All of you understood this well?
Yes, ma'am.
Yes, ma'am.
All right, finished writing, children? Please take a screenshot if you have not finished. Please take a picture if you have not finished. All right. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you, children.
Thank you, ma'am.
Yeah,
Thank
see you.
you.
Thank you.